Okay, we were talking about AMAX on the topic of parallel lines. By the way, for your home-based learning or midpoint, some of you have not yet gotten it done. Please remember to get it done before Monday. Okay, so on the topic of parallel lines itself, we have covered two key concepts. One, which is on your angle of inclination, where we know that gradient can be calculated as tangent theta, where theta is going to be your angle of inclination. Okay. Then another concept that we have learned about parallel lines is that so long as there are two lines that are parallel, we can say that the gradient are equal. Gradients are equal. Likewise, when the gradients are equal, it will be able to inform us that they are parallel lines. Then in our last lesson, the last question that I think we went through was in terms of proving collinearity. So, in order to prove that 3 points are collinear, we need to show that the gradients are equal. Okay, and then also to mention the common point. So these are what we have covered with the questions that we have done so far. Okay, I want to just finish up this topic by looking at one more question. us to go and look for, okay, in terms of trying to prove a parallelogram. Okay, so how are we going to prove that the lines are parallel? If I want to use the concept that we are covering so far. So we look for same gradient, right? So now I need to go and look for the gradient of PQ. Okay, by making use of its coordinates. So maybe I'll put in the coordinates here for easier reference. So gradient of PQ, that will be 2 minus 0 over negative 1 minus 5. So that will give us 2 over negative 6, negative 1/3. Okay. Then I want to prove that it is going to be parallel to SR, so I will find the gradient of SR. That will be 6 minus 4 over 1 minus 7. Likewise, it gives us negative 1/3. So since we see that the gradients are equal, okay, then we can say that PQ is parallel to SR. So we have settled one pair of parallel lines. Okay. Then we do the same for the other pair of parallel lines. So we look for the gradient of PS as well as the gradient of QR. And we see that the gradient is 2. So gradient of RQ is also 2, and we can say that with this, gradient of PS equals gradient of RQ. So the two line segments are equal, are parallel. Okay. Well, this is sufficient as the answer to answer the question. What else do I need? Uncommon point. As a reader, if you look through a proof that says all this, do you think it's sufficient to answer the question? You need a concluding statement to answer the question directly. Okay, because now all you have done is only to say that the two line segments are parallel, or rather the corresponding line segments are parallel. You have not yet tied it up to say that it is a parallelogram. Okay, so you need a final conclusion stating that since there are two pairs of parallel lines, which is what you were going for. So you need to interpret, okay, what your calculations and all that you're doing is for. Then we draw our conclusion, and the vertices are of parallelogram.
Could you say that find the length and what's the opposite line? Could you use that?
Okay, so Moses is proposing that we prove it by comparing the length of the line segment. What do you all think? Is that sufficient? To prove that the length of SR is equal to length of PQ and length of PS is equal to length of QR. Is that sufficient as a proof? Okay, this is definitely a valid question because once we go to next year, we Okay, our very last chapter, or chapter 19, we are going to do a proof of plane geometry. There are many ways for us to prove parallelograms. Okay. Looking at what Moses is proposing, to use length of line segment, I would think that it is sufficient as a proof, okay, to prove that it is a parallelogram. Right? Two pairs of parallel lines are equal, will be a parallelogram. Right? Okay. But in this particular question, they actually specify it, saying they're using the condition for parallel lines. Okay, they did not say, they did not want you to, you don't need to ninja in class. Okay, yes, many ways to do parallelogram. In fact, the idea of parallelogram will be very prevalent in our entire chapter. Okay, Yola, are you going to submit to me your WA? Okay, no, so Sunday, email, remember. Okay. Right, so let's move on to chapter 7.2, but before that, let's look at exercise 7.1 homework. Okay, in the sense that I'm giving you homework. Okay, this is a multi-direction homework exercise. I want you to do question 1. Okay, kalau long time no homework, okay.
That's not just the
Okay, just those 4 questions. Due when? Due on Monday, which is what day? Today's 3rd, 4, 5, 6 of May. Okay. You still have WA next week?
Yeah.
You know that very resulting, yes.
computing. Yeah, there's also computing. Yeah. What do you mean I am? As a
Okay, let's move on to perpendicular lines.
Study chapter 1 again. I thought it was Friday. Computing study what? Study binary, right? Yeah, study binary and system. I thought you said Friday, that's computing.
Okay,
That's very extended.
we have learned that parallel lines, right? Your gradients must be equal. Now we're going to be looking at perpendicular lines. What kind of conclusion can we make regarding its gradient? How does the gradient behave? So, if two lines are perpendicular, okay, if two lines are perpendicular and I want to give it an equation. So, for example, y equals to m1x plus c1, y equals to m2x plus c2. So these are just equations of the two lines that I'm talking about. Then we can see that the product of the gradients will actually be equal to -1. In other words, it also implies that the gradient of one of the line will be a negative reciprocal of the other gradient. Okay, the negative reciprocal. Reciprocal means that it's 1 over the number. Okay. So likewise, the other way also works. So long as we are able to see that there is this association, we can say that the two lines are perpendicular. Okay. I hear you say that reciprocal, so in case you don't know how it is being spelled, with negative reciprocal. But being able to present it like that is good enough. Okay, so look at try 4, page 163. We want to find the equation of the line that passes through A, negative 2, 4, and also perpendicular to this line. Okay, so if you had read or rather went through the SLS lesson, I really advocate a lot regarding drawing of diagrams to help you interpret the question. So, we look at this line first, 3x plus y minus y equals to 0. You may want to reinterpret it as your y equals mx plus c form. That will be negative 3x plus 1. Okay, so we know that for sure it is a downward sloping line. Okay, what we want to find is that the equation of a line that is perpendicular to this. So, we want a perpendicular line, something like that. And then this line passes through a point that is A negative 4. I'm just anyhow naming the point. Okay, so I want to know what is this equation of. Okay, we need to keep in mind that every time I need to find the equation of a straight line, I must have two things. What are they? Not as important. I must know the gradient and then also the y-intercept, right? Okay, so these are two things that I must have. So the first thing that we always have got is the gradient. How do I find the gradient of the unknown line? I make use of the given equation over here. And keeping in mind that this is a perpendicular line, not parallel. So your gradient of, so in your working with this equation, you would have rearranged it to find what is the gradient already. So the gradient of required line will be the negative reciprocal of negative 3. So negative 1 divided by negative 3. So we get 1/3. Okay? So I did not go through having to think of the product. Okay? Because I know algebraically it is going to be this one, right? So negative 1 divided by this gradient. Okay? So the gradient of the required line will be 1/3. You can go and go through your y equals mx plus c, form the incomplete equation, or in my previous lesson, I have told you that if I have the coordinates of one of the point, y minus away the y coordinate equals to 1/3 x plus 2. Why is it plus 2? Because minus negative. In case you don't see that, I'll write the equation here. Okay, I'm using the formula, you can see that. Okay, yeah, I thought the other time wrong. Yes, Jaden.
Can you explain the y minus over 1/3?
It is, the y minus
Can you explain that?
is again. Let's explain the formula or explain this. This one. So the gradient is 1/3 one. Then the point is negative 2, 4 now. So this is your y1, 4 is your y1, then negative 2 is your x1. So I just replace. What do you want me to explain? I don't understand. I'm just using a formula. Okay. Then from here, I expand it. So 1/3 plus times 2, so 2/3, then plus 4. So the equation of my line will be y equals to 1/3 x plus 4 is 2/3. Jaden, you tell what you not understand. I don't understand.
How you get that?
How I got this? I use this one. I use this formula. Yeah. Which was a derivation of the gradient. So if I divide this over here, everyone? Everyone clear about this? Or I need to explain further about this formula? Not even listening, not even taking notes, tell me if you clear. Okay, maybe you all try to calculate it out. Okay, so that will be the equation. You okay with it? Okay, so moving on. Okay, part 2, we want to find the coordinates of the intersection point, which is called N. So, naming this point here as N. I want to find the coordinates. How do we do that? I already have the equation of the perpendicular line. What do I need to do to find these coordinates? What do we need to do? Sum it in, solve simultaneously. Okay, so can you please do that now? Give you 3 minutes to go on that. Are you able to get the answer? What should it be? Negative 1.1 and 4.3, right? You get it? Okay, so you equate them, you will be able to get this when you sub 1 equal 2. Then you can multiply by 3 across. So get rid of the denominator, 1240. Okay, that is my preferred way of doing that. Alright? Then I'll get negative 9x plus 3 equals to x plus 14. So 3 minus 14 equals to x plus 9x. So we get 10x equals to negative 11. So x is negative 1.1, and then your y, okay, sum it back into equation 1, and we will be able to get 4.3. So our coordinates of n will be negative 1.1 and 4.3. Okay. Next, we look at part 3. Okay, so looking at part 3 itself, we want to find the shortest distance. What do we understand about shortest distance when we learned about it in Sec 2? Do you all remember? There's this important thing about shortest distance. Okay, so earlier on, sorry, you made the diagram by accident. We have a line that is your 3x plus 3x plus y minus 1 equals to 0 already. And then we also found the equation of the perpendicular line, which passes through the point negative 2, 4. Okay, and then this line has the equation y equals to 1/3 x plus 4. Right? So n is actually referred to be the point of intersection here. We want to find the shortest distance between A to N. Okay? I want to get from my placing here all the way to where Gareth is sitting. Okay, what is the shortest distance? How can I find the shortest distance? Okay. I go the straight line, right? Okay, and it must be perpendicular, okay, to that line that we set up, okay, that horizontal line, that from my point of view. Okay, so maybe that is not a very good example. What is a better example? Okay, the problem here is that because the lines are already perpendicular, the shortest distance will have to be just directly the length of this A and N. Okay, so we just have to use the formula to find out the length of A, the shortest distance, okay, from A to N. So your x coordinate difference, y coordinate difference, then you'll be able to get with the equation of CG as y equals to minus 2x plus 7 equals to 0, upon manipulation, to arrive at y equals to 2x minus 7, you will be able to tell that the gradient of CD will be 2, which also means that the gradient of AB will also be 2. Because AB and CD are parallel. Okay? After I have achieved the gradient of AB, I will be able to get the equation of the straight line already, because I know that the coordinate AB is 6, 15. That is already a point found on that line itself. So, your equation of this straight line will be y minus 15 equals to 2 times x minus 6. And I will get y equals to 2x plus 3 as my equation of AB. In part 2, we want to find the equation of BC. How can I find the equation of BC? I call another name. How do I find the equation of BC? Perpendicular. It is perpendicular to what? AB, so it's perpendicular to AB, also perpendicular to CD. So what would the gradient actually be? We can get negative 1 divided by 2. Because the gradient of AB, we already know that it is 2. So because of the perpendicularity of BC and AB, I'll take negative 1 divided by the gradient of AB. Okay. So the equation of the line BC, since I also already know the point of BC to be 6, 15, I will be able to form my equation this way. And I'll have y equals to negative 12x plus 18. Okay. Then in part 3, I want to find the coordinates of A as well as the coordinates of C. Okay, finding the coordinates of A is much simpler. How can we find the coordinates of A? If you, what do you think? That there's only one to discuss, right? Make x 0 into 1. Into which equation?
Y equals to x.
Okay, into this equation here. So A is the point found on the line AB, for which it has this equation, y equals to 2x plus 3. So, because A is a point on the y-axis, that means its x coordinate will be 0. Hence, I can find that your y value will be 3. Alternatively, you can also see that A, the y coordinate itself, is none other than the y-intercept of this line. Okay? So therefore, your coordinates of A will be 0, 3. Now, how about the coordinates of C? How do we find the coordinates of C? Let's get it from someone else. Moses. How to find the coordinates of C?
Take 2x plus 18
Oh,
equals to minus 2x.
half x plus 80 equals to minus 2x plus 7.
No, equals to 2x minus 7.
Okay, so what we're trying to do is to see that C is the intersection point of the line BC as well as DC. So I have the equations of these two lines already. So I will solve them simultaneously. Okay, either you use this format of the equation, otherwise you can use this y equals 2x minus 7. You'll be fine. So if you do like what I've done here, essentially I'm substituting equation 1 into equation 2. And then I'll have this. So I'll get 2.5, negative 2.5 here, so that's negative 5 over 2x plus 25. So 25 divided by 5 over 2. That will give us 10. And then our y can be found when I substitute x into equation 1. Negative 5 plus 18, that's something. So the coordinates of C will be 10. Okay. So found the coordinates of A as well as the coordinates of C. Any questions? Okay. Now to find the area of the trapezium, at this juncture, okay, we only know one formula for area of trapezium. Alright? What is the area of trapezium formula? Okay, half times sum of parallel lines times the height. Okay, and it will be a very tedious task to go about doing it, okay, for this question. Because you need to go and find the length of AB, find the length of CD using your formula, and then also have to find the length of BC using your length of line segment formula. Okay, I will not go and pursue part 4 because once we arrive at chapter 7.4, we have a much simpler formula that will help us calculate this area, okay, in an easier manner because we have coordinates. Okay, so in case you want to know how it looks like now, okay, we will use half times not times 3. We will have to use this modulus brackets, okay, 0, 3, 2, negative 3, and then 10, 13, and 6, 15, and 0, 3. Okay, we will be using a formula looks like that. Okay, I'm not going to cover it, alright? It will give you the answer very easily. Okay, I'll come back to that when we reach chapter 7.4. Okay, I want us to move on to try 6. Okay, so we're given this diagram here. information is also in the diagram. We want to first find out the equation of PQ. How can we find the equation of PQ? This one doesn't require any of our Amex concept. Jada, what do you think? How do we find the equation of PQ?
Find the gradient first.
Okay, find the gradient of PQ since we are given the coordinates. That will be 5 minus 1 over 3 minus negative 1. And we get 1, right? Okay. Then we go ahead to find the equation. You can go and do your y equals mx plus c if you want to. If not, what I'll do is just take one of the coordinates. So I'll take 3, 5. Y coordinate is 5 equals gradient times x minus 3. X coordinate is 3. So I will get y equals to x minus 3 plus 5. For my step here, I'm just currently expanding and shifting the other term over. I hope you are able to see that. Then I'll get the equation y equals x plus 2. Okay. Next in part 2, I want to find the equation of FR. So the equation of PQ has already been found, which is y equals to x plus 2. How can we find the equation of FR? Let's see, Aaron. How do we find the equation of FR? It's a straight line. We need the gradient. What will the gradient be? Okay, so we take negative reciprocal of PQ's gradient. So essentially what we're doing is gradient of FR equals to negative 1 divided by what's the gradient of F of PQ? It's just 1, right? So the gradient of FR will be negative 1. Okay? And then your equation, like this, your equation of FR will then be found by recognizing R's coordinates has already been given, which is on this line. So we get 4 negative 1. So y minus negative 1 equals to gradient negative 1 x minus away x coordinate. Hence we get y equals to negative x plus 3. That will be the equation of FR. for the equation of y equals x plus 2 and y equals to negative x plus 3. Since f is the intersection point of the two lines. So f will have the coordinates half and 2.5. Okay. Okay. In part 4, we want to find the ratio of PF and Q. If you had watched the video for midpoint already, you will find a question like this looking familiar. I have explained it in the video. Okay. PF to FQ itself, the question itself makes you think of maybe finding the length of the line segment PF and then also the length of the line segment FQ. And then you literally go and find the ratio. But that is not the most efficient way to solve it. Okay? If you watch the video, you will notice that it's not efficient at all. An efficient way to solve, to find out the ratio of PF to FQ is that we recognize that there are similar triangles over here. Okay? And in similar triangles, one of the properties that comes out of similar figures is that the corresponding sides are proportional to each other. So, if I want to find PF is to FQ in a ratio format, the equivalent in its fractional format will be PF over FQ. Okay? For which it is equals to, let's say if I call this point X and I call this point Y, the corresponding sides of the two similar triangles will be fx over qy, and then also px over fy. Keeping in mind that my choices in the numerator, they are all belonging to the triangle pfx, and then the sides that are found in the denominator will be from the triangle fqy. Okay? So, I can go ahead to find out what is the ratio for one of them will do. I don't need to find both. So, let's say if I want to find fx over qy. Okay? What is the length of fx itself? I know that f has a y coordinate 2.5. X has a y coordinate of 1. Okay, because of this point here. So it will be 2.5 minus 1. That will be the length of your fx. For your qy, okay, it will be the difference in the y coordinates. So this one, this point here has a y coordinate of 5. For this point, it has the same y coordinate as f, which is 2.5. So we get 5 minus 2.5.